Good afternoon, and welcome to Azure Health Data Services on Hyperscale. If you're here for the session, come in and sit down. If you're just here to hang out, I'm sure I have some also interesting information. So let's get started. Okay, who am I? My name is Brendan Kowitz, and I work as a software engineering manager at Microsoft. And my team work on the Microsoft FHIR products, so Azure API for FHIR and the Health Data Services. I live in the beautiful Pacific Northwest and have done so for about the last 9 years. The accent is a little confused because I did move from Australia, so if a few of those accent things come out, that's all it is. I think I've mostly assimilated, so hopefully that's all good. All right, so what are we talking about today? So the main topics I had today was FHIR data at Hyperscale. So a big milestone for Health Data Services, which is our newer offering, is the removal of the 4 terabyte limit to use Hyperscale, which brings that data limit all the way up to 100 terabytes. So I put in brackets, that means data plus indexes. And I'm going to give everyone in the audience here like a little fact that we're going to store for a bit later on. So what that means if you're just looking at Cynthia data is the data portion of it, because we compress it down when we store it, turns out to be about 20 to 30% of that size. So just remember that. So we got 20 to 30% is the data part, 70 to 80% is the indexes that you need to go and retrieve that data. So we're going to come back to that fact. So let's put that in the back of our mind for now. But as we've increased this data size to 100 terabytes, it's not just enough to simply add the capacity. So we really wanted to make sure as we were growing the data size of Health Data Services that we really had hand on heart, like, yes, this data is useful. We can support all the operations that you need to do. So it's about enabling that data capacity as much as it is just adding it. And the way that we have enabled data capacity is sort of enhancing a lot of the bulk operations that we offer, including sort of adding some new bulk operations that I guess are right now outside the spec, but they are sort of heavily asked for amongst the requirements that we have. So what are they? Hopefully that's not too small, but I have a nice little circle here. So we'll be talking about the changes that we've made to the import operation, export. We have a new bulk delete operation as well, and also a selectable search feature. So we'll discuss that one a little bit more in detail as well as what is behind the scenes in terms of like scale up and scale out. And of course, I really want to share sort of some of the perf challenges that we've had sort of along the journey, just in the spirit of kind of like openness, but also sort of learning against the FHIR specification. So first up, import. So per the spec, it solves the import problem to the basic degree just fine. But what we sort of discovered as if you have a lot of FHIR data that you're trying to get into the system, maybe you want to support history from one or more downstream systems. So what does it mean to support history? Well, it means respecting the last updated field and maybe optionally even sort of the version field as well. But that's kind of weird for a FHIR server because pure FHIR servers are mostly that's controlled by the FHIR server itself. Like, it sets the last updated, it sets the version. So a FHIR server now respecting that, it's kind of, a little outside the bounds of norm. But if you are looking for that full sort of system synchronization, then it is necessary. The other thing that you need, if you're looking for that full sort of history import, is the ability to sort of read in soft deleted operations as well. So what did we do? Well, we did those things. So we introduced a new mode called incremental import. So what's different about this? So we already had a initial import mode. Initial import is completely free. We want you to get your data into Azure as fast as possible. Incremental import sort of goes above and beyond, where it does support the last updated fields if it sees them written into the resources. It also supports a soft deleted extension, so I'll show you exactly what that is in a minute. And we changed a few things around to make it, we basically revamped the entire infrastructure it runs on, so it's more distributed, it's more parallel, and out of the box, it does support the out-of-order processing. The reason why it does that is because it chunks up the imports so much that it could process future records before past records, but it kind of figures out the order as it brings it into the system. If you want to see the full API specification, there's a link at the bottom and also in the handouts provided. But I want to also give an indication of so how fast is this revamped import? So when we turn up the dials sort of all the way to the right, we have seen sort of on the Cynthia data again, pull in about 14,000 resources per second. So what does this number mean? Just to give it a little bit of context. So we have some really smart SQL guys working on this now, and they don't like the server operating on anything but the theoretical maximums of SQL Server. To them, unless the SQL Server is writing its maximum T-log rate, they are not happy. So they've kept sort of refining and optimizing that code until the constraint basically become the database. And in this case, when all of those things are scaled up, we got about 14,000 resources a second with full default search parameters enabled. So how does it work? It is the same as the initial import mode, so posting to the operation to the $import operation. And I wanted to show these as kind of FHIR path expressions as opposed to bombarding you with a big blob of JSON here. But if you're posting up the parameters object, the only change here to make it an incremental load is by setting the mode value to incremental. Pretty easy. How do you detect soft deleted resources? So again, I've used the actual FHIR path that we use inside the service. So if you have a meta extension where it has a deleted state of soft deleted, we will respect that and persist that into the history as a soft deleted resource so you can synchronize in the full system history. And it really wouldn't make a lot of sense if we didn't also make this exact same improvements into the export functionality. So we do now have the option for you to export your entire FHIR server, including all history. So it also supports the soft deleted resources. They will write out as well. We revamped the infrastructure so it's fast, highly parallel. If you want to look at the full API, got the link down the bottom, also in the handouts. What do you need to do to include those things in the export? So I don't know if you can notice here, but something I've learned also at FHIR DevDays is I've actually mixed version 1 and version 2 of the bulk FHIR specification here. So we're recommending, I think, posts to the export endpoint now. But in version 2 of bulk FHIR spec, you can use the include associated data. And the two custom parameters that we've included here is history and deleted. So you can include both or optionally one or the other, and we will export full history and also all your soft deleted resources. Again, we wanted to see how fast is this thing if we turn all the dials right up to the right. And when we do that, because we are not sort of ingesting and indexing things, we were able to get this thing up to 1 million resources written into storage a second. If you're talking about 100 terabytes of data, that's billions of possible resources that you could be storing. So it only makes sense that you need these operations to kind of support that volume of data. Okay, the next operation that we have introduced to help manage vast quantities of FHIR data is bulk delete. So we do have a lot of sort of requests for data retention policies to be applied. So you might have sort of time-based data retention of hey, I only can keep this data for 2 years and then it needs to disappear. Sort of segmentation-based stuff where it's this provider left us or something like that. So you may have sort of segments of the data that you need to delete based on these requirements. We also support both soft and hard deleting the data as well, because sometimes the data just simply needs to be gone. It's also useful in dev and test scenarios, believe it or not. We do from time to time get the request to say, hey, Microsoft FHIR team, can you just delete all the data in our database and let us start again? We really don't want to be deleting any of your data ever, so we have this capability now to fulfill that requirement as well. Again, it's built on the same asynchronous high volume framework as the other operations. It works on the system level, it works on resource level. You can even sort of purge history as an operation, and you can also operate bulk delete on any arbitrary search criteria. So one sort of need I see as organic growth of pure FHIR servers now is that we have introduced bulk delete, but it also exists in a sense for $purge and I think also $expunge. So I think these bulk data operations are sort of coming into FHIR as we acquire these sort of vast quantities of data. How does our bulk delete operation work? Again, not going to spend a lot of time on these, but you can simply do a delete to the $bulk delete operation. In this case, it will search through the entire server based on the search criteria of tag, delete all that data. The next one down here is saying, hey, just bulk delete, hard delete all my patients. I don't probably recommend this one, so we do offer an action and a data role that you can assign to your clients so that, of course, not everyone should be doing this. So you can restrict that only to a more privileged group of clients to be able to hard delete things. We also omit audit logs so that we know exactly who deleted what. And the last one here is showing a bulk purge history. So it's like, hey, I don't want to keep any more of the history on my FHIR server because I only do a one-way sync. Well, you can use the purge history operation to sort of clear all that out. Selectable search parameters. Okay, so this one here, we're going to bring that little fact back that we were discussing right at the start. So we had the 20 to 30% as data, 70 to 80% is all indexes. Selectable search parameters, which we still consider to be in preview, allows you to turn off the default search parameters from the spec. So if you don't use them, well, now you have the ability to kind of manipulate those numbers and potentially store even more FHIR resources in that 100 terabytes. So by turning off the unused search parameters that you might never use, you have more efficient search and even import, because it's writing so many less records, can double and sometimes even triple that already big number. So yeah, we're quite excited about this one as well. And to use this, we've added a status operation onto the search parameter resource. You can search for things by code, and all you need to do is to do a put to the status. And here we're using the URL, which is kind of the unique part of the search parameter. Sometimes they do apply to multiple parameters, so I guess be wary of that. And in this case, it's kind of like a request. So in this case, I'm saying, hey, the clinical date, I'm requesting that you be supported. After this, I would still run a reindex operation. Reindex will make sure all your indexes are consistent with the change to the search parameter, and then reindex will finally set it into the final state. Okay, so talking about the scale-up options here as well. So on Hyperscale, you have the ability to scale all the way up to 128 premium vCores. Like, these are not the efficiency cores that are, in my dev laptop. These are the premium, vCores that are meant for serious work. I mean, if I could get 128 premium vCores in my dev machine, it would be a game changer, I'm sure. But these ones are huge, powerful servers. And if that's not enough, you need more. We also added support for read-only replicas. So you can now scale your searches out to not only the 128 vCores, but you can have 4 of those replicas for the read-heavy sort of search scenarios as well. This one also can work in the open source. So if you spin it up in your own subscription onto a Hyperscale instance, you can turn all the dials up as far as you want. I guess cost kind of might balance out there, but it is possible. Okay, and then moving on to sort of the final part of this is, I think, just wanting to sort of share a learning about FHIR's flexibility and how that is challenging for a database schema, and especially as you start growing the data, mistakes you make, they amplify. We all know FHIR is highly flexible, highly extensible. Even FHIR's lists seem to have lists. Search parameters as well, you can have, for the same type, very high, low cardinality, and very, low and high cardinalities kind of being stored in the same place, which is a huge problem. And I wanted to show, I guess maybe a little graphically about what that problem is. So this is an example from our schema called token search param. Token search param has a couple of fields here. So, hey, it's got the resource type, it's got a surrogate ID, it's got the search param ID. So these are kind of the SQL links and the code. And if you look at the data distribution, it's like, okay, focusing on patient here, half of the index rows that I've written are for the search parameter gender, and the other one are for identity. But if you look at the uniqueness, identity is almost all unique, and gender only has a handful of values. So we've had investigations where we had noticed that sometimes queries were getting terrible performance. And we pulled out the query plans, and we can see them. We can see the bad one, and we can see the good one. And we're like, SQL, why would you ever pick the bad one? Like, the good one is sitting right there. You should just use this. It is because it is confused because of the cardinalities in such sort of a vast pool of data. But we did find a way to fix it, which I think was very elegant. So we were able to create filtered statistics on 3 of these rows. So the type and the search param and the value code. So now it had a very good idea about the cardinality of the search you're about to do, and it would, I think, always pick the correct query plan sort of going forward. So that one, to us, was a really good enhancement, and I guess improved searches on vast quantities of data going forward. Okay, so I wanted to sort of summarize everything we've talked about today. Again, it's only a 15-minute community talk. So we have adding versus enabling the data capacity. So again, it's not just enough to say, look, hey, now you can use 100 terabytes of FHIR. What does that actually mean? How is that useful to you as a customer, as a FHIR client, as an application? And I sort of see that maybe in the future there'll be this sort of continued trend of like, now that we have these giant FHIR servers, we need sort of a new set of capabilities sort of set in that bulk data sort of, operations and management sort of space. So just to summarize the ones that we have here, so import, export, bulk delete, selectable search, the perf, and scaling in and out. So find me at DevDays in the Hoover speaker gallery. My team's email address, FHIR@Microsoft.com. I'm also on social media. I do plan to hang out at the Microsoft table after my talk as well, if you want to come by and say hi. And I believe we have a few minutes for Q&A. So leaving you also with a very FHIR meme that I feel like happens to me. So you talk to an expert about the FHIR spec only to realize you didn't know as much as you thought you did. So all right, yeah, thank you. I think there is a question over here. Maybe if you tell me, I can repeat it if you like. Oh, the mic's coming. Okay.
How does your team decide what features to add? For it looks like you're adding, or you just added these features. How do you decide against what and when you add what features to the product?
It is a good question. So to answer the question, how do we decide what features to add to the FHIR server? So I think from the very beginning, we have had the approach where after we kind of covered, I guess, all the basics of FHIR, we then sort of very much sort of looked at both the demand from our customers and the requests that are being made on us. So, where we sort of have enough, I guess, customers asking for certain capabilities, then we sort of investigate adding those. Sometimes it is, a defined operation from the spec, which makes it easy. Sometimes that operation in the spec is not as defined as we would like, which makes it a little bit harder. Again, that's what FHIR DevDays is all about. And then sometimes it is capabilities that might not even exist yet, because FHIR is a developing standard. So all of these, yeah.
Hi, it's a follow-up question, really. So is there parallel efforts from your team to try to get some of these operations, either if they're in their kind of proposal state, like the import, which has multiple kind of proposed solutions, and then some of the new ones you've implemented here, to get those added to the spec as well?
I mean, I would love that.
Okay.
So in places that we can follow the spec as closely as possible, like in export with the included data, I feel like we've already done a pretty good job, and the spec does say like you can use custom fields with the underscore as well. If, I guess if the other FHIR servers feel there is a need for that, I guess that makes sense. But in our sort of customer workflows, that is what was required. For this like bulk data operations, I feel like there will definitely be more discussion in the future, for sure. Yeah. Yes.
I'm trying to see in the specs what happens when you do a bulk delete with the references.
I have heard rumors at DevDays that is coming, right? Bulk deletes with references. I think that is also something our team will look at in the future. Like that is on our radar. I don't have, I guess, any other details right now, but it definitely is an ask. Yeah.
Thank you.
Yes, could you speak a bit more about the incremental import functionality that you mentioned?
Yeah, anything specific?
Just now, just again a little bit of an overview of how it's working.
Sure, yeah. So incremental import is a fully online operation, which is the biggest difference to what we had before. So calling import to the incremental mode, it gives you that enhanced functionality to respect last updated, to also import soft deleted if they are there. If you're not doing those things, I guess the advantage is that the FHIR server stays fully online for transactional workloads and searches while you sort of pull that data in incrementally. I guess that was the original intent of the name, yeah. Yep. So, yeah, I think that's it. So, yeah, thank you everyone for coming, and it's been a pleasure to be here at DevDays.